I know. I've done a whole lot of implicit differentiation problems on my channel before, but truth is, it's one of the harder topics in calculus. I know for me, it took me a long time and a lot of practice to learn implicit differentiation and what it was really doing and what you're actually solving for when you're solving implicit differentiation problems. And especially when you have to consider that they involve product rule and chain rule. So in this video, I wanted to show you an example that I had from one of my live streams that I've been doing every Monday night at 5 Pacific, 8 Eastern time, which was an implicit differentiation example involving chain rule and product rule and implicit differentiation all in one. Because the more you practice these types of problems, the better you're going to get and the easier they're going to become for you. So without further ado, let's go ahead and jump into this example. What we're going to do is we're going to find dy dx given this equation here, y squared equals 3xy minus x squared. So really with any implicit differentiation problem, any time you're trying to find dy dx, or the other really common one is like dy dt, but really whatever it is, if you're trying to find this like d one letter over d another letter, doesn't really matter what those two letters are. That right there actually gives you a ton of information that you're going to want to keep in the back of your head as you work through this entire problem. So what this tells you right here, if we're trying to find dy dx, d anything over d anything else, we'll just say d squared over d triangle, whatever these two things are, it doesn't matter. What this tells you is whatever this thing right here is on the top, that is going to be treated as a function, and whatever this thing here on the bottom is going to be treated as your variable. So in this case, we have dy over dx, y is a function, x is a variable. So I like to recommend writing this out right off the bat. Keep straight what's your variable, what's your function, because as you go through this problem, what you're going to do, whatever's your variable, whatever's on the bottom down here, you're going to find the derivative of both sides of your equation with respect to that thing. This is going to tell you exactly how you're going to deal with taking the derivative of these different pieces based on the fact that x is our variable and y is a function. And the reason why that is whenever you're taking the derivative of whatever your function is, in this case y, you're going to want to find the derivative of that term using the chain rule, because we don't know what this function y is. So if you don't know what the function y is, you can't possibly know its derivative. We can't find the derivative of y if we don't know what y is. So what you'll kind of run into basically is whenever you're taking the derivative with respect to x of y, or whenever you're taking the derivative with respect to your variable of your function, you're not going to be able to actually find that derivative. Instead, you're just going to write that as dy dx, which literally just means the derivative of y with respect to x. So as we go through this now, let's kind of keep that in mind. Anything that just has x in it, finding that thing's derivative is going to behave the way that you probably expect. You're going to be able to use power rule, product rule, chain rule, quotient rule, any of that kind of stuff as normal. But anything with a y in it, we kind of have an extra step based on the fact that y actually represents a function rather than a variable. So let's go ahead and actually go through this derivative step of this example, and I'll kind of explain what I mean by that. As we're doing this, we basically can just kind of go term by term and think about each of these three terms here, one on the left side of our equation and then two on the right side here. And as we go through and take the derivative of these things, keep in mind that x is your variable. So when you're taking the derivative of y squared, like I said, y is a function. So really what we have with y squared is you want to think of this as a function of x, all being squared. So if you were trying to take the derivative of something like this, you would need to use chain rule, because you have a function here within parentheses basically being raised up to a power. So chain rule says we're going to take the derivative of the outside function, the derivative of this squared piece, and leave the inside alone. So we'll bring the 2 down in front, leave the inside function alone, which is just y, and then lower our power by 1. 2 minus 1 is just 1, so 2y to the first is just 2y. And then by chain rule, we have to multiply this by the derivative of the inside function. Well, the inside function is just y, and like we said up here, the derivative of y is just dy dx. Okay, then over here on the right side, we have, basically 3x multiplied by some other unknown function of x. So what we're going to have to do here to find the derivative of this term is use product rule, where we basically can treat 3x as one of our functions and y as our other function. And we'll just kind of break that down over here. So we'll just say f is going to be our 3x, g is going to be y. So this product rule formula, chain rule formula as well, both these things are on my Calculus 1 study guide. It is free. If you want to go grab a copy of that right now, you can do so. There's a link down in the description where you can get that for free right now. And that actually would be another great tool for you studying for finals coming up. So go grab that real quick, pull that up, and I'll show you, this formula right here is just the product rule formula, which is on there, which basically just tells us to find the derivative of f times g, 3x times y. We need to figure out the derivative of each of those pieces, first of all. So the derivative of 3x with respect to x, we're taking d dx. So derivative with respect to x of 3x is just 3. And then the derivative of y, again, is just going to be dy dx. And then product rule says that we're basically going to multiply these across and then add them together. So we're going to get 3x times dy dx, and then 3 times y, and then add them together. And then for taking the derivative of minus x squared, that's just going to be straight up power rule. That's nice and simple. Bring the 2 down in front, lower the power by 1, giving us 2x. So now, really, with any implicit differentiation problem, the next step that we want to kind of go to is to separate our dy dx terms on one side of the equation and our non-dy dx terms on the other side of the equation. So you can see basically thinking about the different terms we have here, we've got one term here with dy dx in it, one term here with dy dx in it, and then one term here without a dy dx and one term here without a dy dx. So basically we want to get these dy dx terms over on one side. We'll leave the non-dy dx terms over on the right side of our equation. So basically we'll just have to subtract this over to the other side. Or in other words, just subtract it from both sides of the equation. It'll cancel over here, and we will have 2y dy dx minus 3x dy dx equals 3y minus 2x. And then once you have gotten all of your dy dx terms on one side of the equation, typically what you want to do at that point is, since now everything on the left side here has a dy dx in common, what we can do is we can factor that dy dx out of the left side of our equation. So pulling dy dx out of this term is just going to leave us with 2y. Pulling dy dx out of this term is just going to leave us with minus 3x. Right side is not going to be changed at all. And then now the reason why this is so nice is now we've gotten this to the point where we only have a single dy dx. So what that means is all we can do to basically get that all by itself is just divide all the other stuff that's in parentheses here from both sides of our equation. And that's just going to leave us with dy dx equals 3y minus 2x over 2y minus 3x. Well, I hope you found that video helpful and it helps make implicit differentiation problems a little bit easier for you. If you haven't already checked it out, implicit differentiation is actually covered in my complete Calculus 1 package. There is a link down below if you want to check that out for yourself. It's all available instantly if you do decide to go grab that. But if you found this video helpful, please be sure to hit that like button down below, subscribe to my channel as well, and hit that bell icon and turn on all notifications so you know when I'm going live. Hope to see you next Monday night.